Hello everyone, I'm here to present hierarchical subspace learning for dimensionality reduction to improve classification accuracy in large datasets. My name is Paris Saharavi and my co-author is Dr. Winston Goddard, and we are from EC Department of University of Waterloo. Today's datasets are becoming more complex and high-dimensional, having too many features that can hinder our intuition and vision of data. By driving the data to a lower dimension, we give users a degree of freedom to reproduce most of the features while providing us more data explorability and visualization. Data dimensionality reduction produces a lower dimensional encoding of a given high-dimensional dataset. Two common approaches to achieve a lower dimension is feature selection and feature extraction. Feature selection selects the best subset of features to build machine learning algorithm on. In this paper, we use chi-squared feature selection to determine whether a result is statistically significant or just occurred by chance by using hypothesis testing. Feature extraction transforms the input space onto a lower dimensional subspace by creating a new feature space. This feature space is not a subset of the original feature space, but an entire set of new features based on the original dataset that usually improves or maintains the accuracy while simplifying the complexity of the model. In this paper, we have used both supervised and unsupervised feature extraction methods such as PCA, ICA, FDA, and GDA. To compare the accuracies in this experiment, we have used 4 different classifiers, such as k-nearest neighbor, which uses the known labels of the closest points in a training set to predict the class of each data point. We used Euclidean distance metric in KNN that does not weight the distances between the points and sees all points as equals. We also used the linear discriminant analysis LDA classifier that uses linear decision boundaries to distinguish the classes. We used QDA, that is the quadratic form of LDA, and also random forest that takes the majority vote from ensembles of decision trees. In this paper, we have proposed a hierarchical approach with a stratified sampling. The general idea is that we consider the points within some hyperspheres in data space, and we sample from the points of the hyperspheres with a stratified sampling. Using the sample points from every hypersphere, we can apply the desired feature selection method and our feature extraction method. First of all, we consider many small hyperspheres, and in the later iterations, we reduce the number of hyperspheres but increase the radius of them. This is because at first we want to make small changes to groups of data points, but later we want to explore more of the data space. Moreover, we reduce the size of a stratified sampling and reduce the feature extraction portion at every iteration. We then apply our manifold learning method in every hyperspheres. We find the projection matrix denoted by U, and we project all data points using that projection matrix. For the experiments, we use 5 publicly available datasets, which are Fisher Iris, Breast Cancer Wisconsin, which is a digitized image dataset, Isolate dataset, which is a digitized voice dataset, MNIST and ORL that are both image datasets. We split the data with trained validation test sets with the setup that you see. In general, you can see that the hierarchical approach has improved the accuracy in almost all cases for an average of 2%. Here we have highlighted all the improved hierarchical accuracies in all categories of different feature selection methods and different classifiers in red. The simplicity of the datasets such as iris and breast cancer causes compatible accuracies in most methods. But as the number of attributes increases, the gap between the original method accuracy to the hierarchical approach is more clear. But in some cases, the hierarchical approach gives us even higher accuracies than raw data, especially in the case of PCA. In these cases, projected space has more information on the outcome compared to the raw data. No feature selection gives us higher accuracies in hierarchical approach than chi-squared feature selection because it gives us more feature space to work with. However, it takes longer to run due to projection matrix being bigger. Result analysis in more details is available at long version video. The runtime in smaller datasets, such as iris and Wisconsin breast cancer, is not significantly different. However, as the dimensionality of the dataset increases, especially with a greater number of features, the runtime increases. This increase is predictable due to the hierarchical nature of the algorithm and the dependence of a classifier's time and space complexity on the input matrix at every iteration. To conclude, we proposed a hierarchical approach to improve the accuracy of submanifold learning method with the cost of its runtime to pre-process the data. For future directions, we can improve the runtime of this method and also test it on nonlinear manifold learning methods such as kernel PCA or kernel LDA. Thank you for watching this video and listening to our presentation. I'm available for any question.